Out there in the North Sea in 1960, they launched the great gas gamble. It took 3 years of probing before they found gas, and it wasn't until 1965 that they knew for certain that they had a commercial proposition, and potentially the greatest access of power to this country since the Industrial Revolution. This is the story of the advance of North Sea gas into Britain, an account of how they strung, jointed and buried a pipeline to link the sea terminal on the Norfolk coast with homes and industries all over the country. A world record wheat crop springs from the dark Fenland soil, land at up to £500 an acre, and it's through this rich Norfolk earth that the line of the pipe runs. The spread boss and his team can move in on the job only after negotiations about the right-of-way have been concluded, only when the agents of the Gas Council have agreed with the farmers and landowners the whole route across country and discussed compensation for loss of crops during the operation. All construction projects need space. Plant and equipment on a large scale need room to maneuver. To build this pipeline for 33 miles, they need a path about 100 feet wide right across the Fen country. A right-of-way fenced off and cleared before the mechanized army can begin its assault. It's sad, but it's inevitable. Of course there are areas like this woodland which everyone would wish to spare, but it simply cannot be bypassed. The most thoughtful consideration goes to the layout of the route. It has to go across country to avoid built-up areas. Disturbance is cut to the minimum, and the first consideration is the farmer. Topsoil, the Fen farmer's rich black capital. Itself the product of generations of careful farming, it's the first consideration. Only after this topsoil has been carefully placed to one side for safekeeping does excavation begin. And there's the farm's drainage to be considered. Whenever the right-of-way has to cross a ditch, and the Fens are seamed with dikes and ditches, and where the line divides field from field, stock and farm machinery must have means of access left open. Only after this can the pipe-laying operation begin. The pipes are 40 feet long, 36 inches in diameter, 5/8 of an inch thick, and weigh 4.5 tons. The trucks deliver them along the right-of-way, and then the cranes swing them off the transporters and maneuver them into the exact position. This is known to the pipeliners as stringing. Strung out along the right-of-way, the pipes are nudged into a precise alignment with each other by means of a jig. Each pipe length lies on the exact spot where it will need the least possible further handling during the operation. It saves time. The Fens are flat but scored with dikes and ditches, and wherever the pipeline has to pass under an obstacle of this kind, or where the line makes a change of direction, the pipe sections have to be bent. The exact amount of bend has already been worked out. A survey team has left instructions for the bending team at every dip or change of direction along the line. There is a limit to the amount of bend even the most powerful of these bending machines can give to a pipe. Not only that, it's essential not to distort the pipe's circular section or stress the steel too much. This X60 steel is amazingly flexible, but it's tough and springy too. They have to bend the pipe a number of times before it will accept the shape they want to give it. In the case of these pipes, the maximum bend they can give them is 11.5 degrees. Hauled through, hoisted clear, and returned to its proper place on the right-of-way, shaped now precisely for its particular job in the line. The sections lie assembled in meticulous detail, the beads waiting for a string. We come to the heart of the drama, the making and burying of the continuous line of pipe. Clean steel is vital to a good weld, and it must be dry. Welding is the core of the whole operation, the most critical single aspect of pipeline construction. Where the welders work, there's the tension of high-powered technique and jealous efficiency. In a pipeline, as in a chain, the weakest link determines the strength of the whole structure. The firing point. The two pipes to be welded together must be perfectly aligned, and an internal pneumatic clamp does this. It has a long control rod which is fed through the oncoming section. The clamp propels itself through the pipe, which has just been welded, and is stopped at the open end and locked into position. The new section, manipulated by a side boom, is moved towards the clamp. The line-up man signals the last adjustments to finish with a separation of 1/16 of an inch between the two pipes. When that critical gap has been set, the clamp locks the two sections rigidly together. Basically, welding is a means of fusing two metals together into a homogeneous mass. In this case, of fusing the molten metal of an electrode with the parent metal of the two sections to be joined. Semi-automatic methods speed up this process, putting more metal and with greater penetration into the joint than conventional methods can achieve. This canopy completely surrounds the pipe, whose open end is also sealed off. And under the canopy, the melting metal from the welding gun is surrounded by a shield of gas, of carbon dioxide, which acts as the flux. The electrode is in the form of wire fed from reels at a constant speed into the nozzle of the gun where it meets the flow of gas. Air movement would disturb the gas jet, hence the protective canopy. This first of a series of welds is known to pipeline men as the stringer bead. It gives the joint strength enough to make it self-supporting. The line-up clamp can be removed and put in position for the next weld. Within 3 minutes of finishing the stringer bead weld, and while the metal is still hot, a second weld has to be made. It's called the hot pass weld, and they make it with conventional electrodes, as they do all the subsequent welding. They make a second hot pass, called the super hot pass, within 10 minutes of the first. The front-line welders make these 3 runs and move on. Each joint is wrapped so that it cools slowly. Teams of filling and capping welders follow up. They make repeated passes round the pipe until the joint is filled. Each weld uses 20 pounds of weld metal. It may need as many as 8 runs. Welding is the heart of the matter of pipeline construction and calls for great skill and experience. And because success or failure lies in the weld, it is most rigorously inspected. Its entire circumference is radiographed in one exposure by putting a panoramic isotope scanner in the middle of the pipe. Lead reference numbers are bound in with the X-ray film holder so that it's easy to tell if any weld is in question. When everything's ready, they take the radioactive head out of its safety carrier and set it in position. Everybody, inside or outside the pipe, gets out of the way of the radiation. The pipeline has to be protected against the chemical action of the soil. and when the pipe left the factory, it had already been given a thick protective coating. The bare joints are now treated, cleaned, primed, wrapped in a layer of fiberglass, and then a layer of felt fixed on with bitumen, insulated against corrosion and the harmful effects of the soil. The sections are joined together now into the one great snake, and they're preparing the bed for it to lie in. This bucket wheel trencher can, in suitable soil, dig a clean ditch, and it can dig it at the rate of about a mile a day. The ditch here is 9 feet deep, as the indicator wires at the back of the machine show. It's as deep as the farmer wants it to be. The trencher makes easy work of ditch digging and can go much faster than the pipe-laying team. But it is kept close up to them because this is Fens subsoil, pouring out to make a neat bank along the edge of the cut, well separated from the valuable topsoil. And a trench in Fens subsoil will not stand up for very long. The safest trench is the one just cut. There are occasions when the trencher cannot be used, and then it's back to the dragline. Less elegant, but tougher in a bad patch. Across the Fens they used the dragline wherever the more sophisticated machines could not be used. Slung from its side booms, a great length of the pipeline is ready for burial. But before it's finally committed to the earth, there's one more test. The holiday detector quickly finds out any faults which may have developed in the wrapping during handling. The defect is healed with a plaster of hot bitumen. And now they're ready to begin the delicate business of lowering in. It's complicated. It's a matter of coordination. Teamwork. Experience comes here. The first side booms release their load. Then they leapfrog the others to the head of the column. They take the strain on the new section so that the second side boom section can release its sling. Great skill and fine judgment make the job look easy. And the pipeline is well and truly laid. Not all of it though. Some was not quite quick enough to beat the treacherous Fen soil. This is why they kept the trencher close to the lowering in, so that often the trench was kept completely open only for about 2 hours, and that was sometimes too long. Here the pipeline must wait on the side booms while the grabs clear out the caved-in earth to the exact depth once more. You can't farm fenland without a complex drainage system, and trenching makes short work of farmers' land drains. Each one is replaced to the satisfaction of the farmer. A surveyor writes instructions about the drain's direction and tilt, and a team begins the repair. Bags of soil fill in a section of the trench up to the height of the drain, and a plank is laid across them to support the new drainage pipe. It's a pitch fibre pipe, long enough not to be displaced when the earth settles under it. It's a better drain than the old one. Each of these replacements will be inspected by the farmer before the trench is filled. In this fen country, there's a high water level in the winter. The local folk say the sock is rising. The pipe could be floated out of position, so it has to be anchored. 20 feet down is firm clay. Into this the screw anchors are driven and the saddle holds the pipe firmly down on the bed of the trench. The pipeline can't always be laid continuously. Overlaps occur when, for instance, a casing for the pipe has to be driven under a road. A country lane is comparatively easy. They just drive their trench straight across it. It doesn't take long and there's no great hold-up of traffic. But a major road is a different matter. Here they have to drive the pipe casing under it. The thrust bore machine is held by a side boom whilst the auger drills through under the road. Water is the enemy in the operation, and it's dealt with by well points rammed down deep into the mud. A dirty job, but with a dozen points in position, the area is quickly pumped dry. This difficult-looking situation, where an overlap has occurred, calls for the attention of a specialized team, the tie-in crew. First thing is, get the water out, and then clean the place up. It doesn't take long with the flame cutter and beveler to lop off the excess pipe, but it calls for great precision. Clean steel is vital for a weld. The foreman conducts his orchestra of side booms. The mechanical clamp is jockeyed into position and clamped firm. And now it's up to the welder. There's no easy way of doing this kind of weld. They get down to it as best they can. A dirty job and a hard one, and one for very highly skilled men indeed. The pipeline crosses several rivers. The River Nar is a small one and the trench is dredged out by a grab. A coffer dam made with sheet piling retains the river bank and the end of the trench. The profile of the trench must be clean and exactly to plan, and a frogman goes down to inspect it. Since the pipe would float in water, it has to be weighted with a concrete weighting saddle. The whole section for the river crossing has been prefabricated, and the pipeline waits above the dam to be lowered into the trench. They take away the upper cross beams which brace the piling and lower the section further into the trench. As the side booms hold it there, the top bracing supports are returned and the lower ones removed and the pipe lowered to the bottom. Before any pipe is launched, they give it a pressure test. It's pumped full of water up to a pressure well above anything it will be called upon to withstand.
Bit more. Come on, pull your hands out of your pocket. Come on, come on, come on.
In the crossing of the River Nene, they wrap the pipe in 6 inches of concrete, 150 tons of it. That should withstand the stresses even of a river like this, with its great variation between low tide and high, and the possibility of damage by shipping or dredging. The pipe section waits on the bank, while the cutouts on the river banks, built with sheet piling, are excavated. Soundings by the engineers ensure the correct line and level of the trench. The frogman will double-check. And here at the ooze relief channel, the trench is being excavated by grabs on a pontoon. Slowly, with infinite care, they ease the great burden across the water, supported by its barges. Now it is in exact alignment with the bed which has been made for it on the river bottom. And slowly it sinks out of sight. Another job for the tie-in team. But before these final welds are made, the whole line is given a series of checks and pressure tests. The pipeline laying is finished. The giant machines move on to the next job. In huge operations such as this, the equipment is elephantine to a degree which poses major problems of transport. Designed, most of them, to be more at home in rough country than on civilized roads, they can't simply move from A to B. Their journeys have to be planned and supervised. The pipeline is laid, to the satisfaction of the experts, now to satisfy the farmer. Draglines, shovels and bulldozers soon fill in the long scar. Subsoil is put where subsoil should be, consolidated and graded. Like a plastic surgeon, the bulldozer operator spreads the skin of precious topsoil across the operation scar, and soon for the farmer, the face of nature is exactly as he's always known it, restored by the pipeline men to the condition they found it in. A landowner, with the contractor's liaison officer, himself a farmer, examines his property. Everything present and correct: topsoil, drainage ditches, fences, and the state of the soil. A pipeline through the Fens, 33 miles of it, welded and buried in 12 weeks. You wouldn't know they'd been there.